Well, good afternoon. Thank you for coming. My name is Dilip Kumar. I'm a vice president at Amazon. I've been at Amazon for just a little under 16 years. I've done a variety of roles in their consumer business. I've led forecasting, supply chain, pricing. I was Jeff Bezos' technical advisor for a couple of years. And I've had the honor and privilege of being a founding member of Amazon Go since it started about 6 years ago. So I'd love to continue the conversation that I had. It started at the keynote this morning, but if you weren't there at the keynote, no problem. This is pretty much a self-contained talk. So let's get right to it. But as with everything at Amazon, we always start with having a customer tell you about the experience. This is Yuval. This is from our first store in Seattle that we opened in January 2018. Yuval was not the first person who entered the store, but he was determined to be the first person who just walked out. So here's Yuval.
Yuval here, he just walked in. Literally 30 seconds later, you were out the door, and I like what you got here.
It was an amazing, spiritual experience for anything. I mean, it kind of just got rid of the line, but I literally walked in, scanned my app as if I was entering a subway turnstile, took 2 of these, then I put one back. I did put a couple things back, but of course I got my favorite beer, Allegiant Space Dust, got this mug, always good mug, Innovation Amazon, this is amazing, it works. I give so much credit to all the people that put so much time and effort into making this a possibility.
Thank you so much. Enjoy your beer.
Absolutely.
It's 5 o'clock somewhere, my friend.
That was 7 a.m. in the morning, and so priorities. I mean, props to Yuval. So I mentioned something about why did we build Amazon Go? It's a question that we get often, and I alluded to it in the keynote, that people don't like waiting in lines. If you look at your shopping experiences in physical stores, even though they're very well served, the basic physical store experience hasn't drastically changed. You come in, you shop, you wait in line, you pay, and you leave. When we were thinking about this problem, we weren't thinking about, well, we should speed up checkout by 25% or speed it up by 40%. We were trying to envision an experience that said, what if you could eliminate checkout? What can you envision an experience when people can come in, take what they want, and just walk out? No stopping or waiting in line to pay. A much higher bar than saying you're trying to speed something up by 25% or 40%. So that was the genesis, that was the vision. Visions are easy. The stars are the ones that are important because, we had a very, very simple problem to describe, as we had spoken about. People come in, take what they want, and they're let to leave. But invention wasn't linear. Some days it looked like this, a lot of days it looked like this. Most days it was frequently loops and loops and loops. But we were stubborn on the vision that we wanted to deliver on this customer experience of having people naturally shop and just walk out. We had a straightforward equation. We needed to know the customer account that was shopping in the store. We needed to know the interactions that those accounts had with the products in the store, so that when they left, we could tally it up for every customer and send them a receipt. But in the early days, we had many, many different competing technology choices on how to solve this. I'll give you a couple examples. One of the examples was people said, well, people have phones, so you should be able to have them use their phones to be able to add products. Well, it turns out that that works if you're shopping alone, but if you're shopping with a child, then the child doesn't have a phone, and children can also shop, which they frequently do. We'll come back to that in a second. And there were many, many examples where we said that there is going to be instances where we want the customer experience to be as natural as possible, so we were always striving for that in whatever we wanted to do. Our motto in those days, as we were building these experiences, was similar to Game of Thrones characters: don't get attached to any particular idea or approach. Because the longevity of that solution or any technology choice that you might choose might be a week, a month, or a year, probably a little less. But that was okay because it allowed the teams the license to experiment, the license to fail, and to be able to try different things in order to deliver on this customer experience. Think of a thought exercise. You're looking at this slide, but if I were to ask you this question 5 years ago or 6 years ago, to imagine a store of the future, and asked you, what would you like to see in that store? A lot of you, or some of us, at least the initial set of things that we got back from folks, was that they imagined a highly digitized experience where there would be screens everywhere, people are going to be interacting with their phones, there's going to be all kinds of information flashing at them. Turns out, nobody likes to shop like that. There's a lot of things that are very enjoyable in the physical store shopping experience, and digitizing it wasn't the answer. Waiting in lines is not really an important part of your experience, and so that was the thing that was durable. We felt that 4 or 5 years from now, 10 years from now, it's not more likely that you'd be willing to wait in lines than less likely. And the more those things are durable, you can actually start relying on it and build something that can truly transform a customer's experience. So let me give you some examples. A concrete example was we had this notion of we needed to know who the customer account was, and we needed to figure out what our entry experience is going to be. Now, entry experience might seem simple, but when you start thinking about the permutations and combinations that you need to go through, think about this. You could be shopping alone. You could be shopping in a group. Your group could just be a friend. Your group could be a family. We were concerned about throughput. We were concerned about what kind of feedback do we need from the customers, or what kind of elements would make it most intuitive and simple for customers to understand. So we got blocks, and we got started in it to try to be able to figure out what is the throughput going to be. We had no idea of what it is. We knew that we wanted people in and out of the store as quickly as we can, but we had no sense of what the throughput could be. It turns out that it can be very high, and so we didn't want our entry gates to, in any shape or form, be the limiting factor in this, and they're not. But that required us to start very simple. Then we graduated to very simple, low-fidelity mock-ups, where we were trying different things as, what is the most intuitive experience for customers? Is it very simple? Is it more obvious for a customer to come in and place their phone down, or should they place their phones up? Seems like a very simple and a very trivial question to answer. When your cameras are up, the natural inclination is that maybe you want to do it like that. But it turns out that most people weren't doing it. Some were, some weren't. What kind of auditory or visual feedback mechanisms do you want to give your customers so that they know that they're doing something right? Because nobody likes to do something and then say that, oh no, that wasn't the right thing. So we wanted to make it painless and extremely intuitive, since this was the first experience that they were going to have before they entered the store. Eventually, these mock-ups resulted in us building an experience that was very simple. It was intuitive, it was easy for customers to understand, and it was also something that we were able to do where we were able to get people in, regardless of whether they were shopping as individuals or as groups, very quickly into the store. This paradigm repeated itself in almost every other part of that experience of who took what. We needed to solve the problem of what are the products and how do you associate those products to the customers. We had bookshelves. We are a bookstore, a legacy bookstore, original company. We had tons of bookshelves laying around. We had tons of product. We had PVC pipes. And we started building these small micro labs, which grew into largely bigger labs where we were able to test out aspects of our hardware and software. The panel at the back is open because we got so tired of sort of prettying it out for people to come in and shop and do these experiments. So we said that we're just going to leave it open because it was way more important for us to understand people's reactions and how they would be able to get this notion of you could just walk out. So all of these eventually led to things like this. You start small, and then we end up in a situation like this, which I showed this morning, where people are coming in and they're shopping naturally. Now, I mentioned some elements in the keynote this morning as to what makes this problem difficult, but there's a couple other things that you may or may not have thought of. People come in with kids. Kids could be in strollers. Kids could be sitting on your shoulder, and then somebody puts the kid down, and they're running around. There's people who come into the store. Sometimes when you're shopping in a group, one person of your group leaves, the other person comes back. All of these kinds of interactions are very normal, and they're very natural, and we needed to be able to take care of that. You can get a lot more detail about some of the aspects of this in a presentation that my colleagues are doing tomorrow, Gerard and Amit, so please be sure to attend that. Eventually, all of these experiences resulted in us building a mock-up store where we were able to test aspects of our hardware, software, and our customer experience so that it met the bar that we were shooting for, both from a customer experience standpoint as well as accuracy. It's worthwhile for me to mention accuracy and why accuracy was critical for us. We were in the business of generating receipts for customers. The receipts needed to be accurate. If you think about for a second as to what we are trying to do, we're building a transactional level system where your receipts is effectively the order that a customer is building. So we're building a transactional level system where all the inputs that go into that transaction is probabilistic. Who the customer account is, where the customer account is located, the specific item that they may have taken, the specific item that they may have put back. We couldn't hide behind classification boundaries. We couldn't hide behind probabilities. We actually had to make a prediction, and that prediction needed to be accurate, because otherwise we would be generating receipts that said, well, it's a 33% probability that you took a turkey sandwich and a 33% probability that it could be chicken, but it could be something else. So we can't do that. And so we had to do this again and again for every customer that was in the store. So the bar for accuracy, when we think about a transactional system and an ordering system, was incredibly high. And it was important for us to do that. And it was equally important, as I mentioned this morning, is to do it in a way where all of that complexity just disappeared and receded into the background. A lot of problems would have been simpler had we asked customers, every time you pick up an item, show it to us, or every time you pick up an item, you can scan it. All of those things drastically reduced the simplicity of the problem for us. But we were very stubborn that we didn't want to make any of those trade-offs, because we felt that it would deter from the customer experience. And frankly, nobody wants to shop in that way because it's a highly interruptive shopping experience where you have to pick up every item, you have to scan it and put it in your bag. That's not a very enjoyable way that people need to shop. So let me start peeling back the onion a little bit more on some of the experiences. I use this analogy of an iceberg of what the customer sees, but then there's a lot of things that are happening behind the scenes in order to be able to create this experience, both from a hardware standpoint, software standpoint, research standpoint, and bringing it all together. So the very simple customer view of this is you have an app, you use the app to enter the store. Anything that you take from the shelves gets added to your virtual cart. Anything that you put back gets taken out. And when you're done shopping, you can just walk out and you get a receipt. So now let's peel that onion a little more to see what else might be happening. So when you think about what we needed to do, we needed to manage this notion of a session for a customer. You needed to know who's entering. You needed to know who's leaving. Why is this important? Well, session management in general is important, but it can also get very thorny because imagine you're entering with a group, that you and a friend are entering, and you go off in two different places to shop. Well, your friend could leave the store before you, or you could leave the store before your friend, but you can't close the session. You still need to be able to keep some coherence of the session that they were associated with, and to be able to charge the right person for the purchases. These kinds of things become really critical. We talked about this notion of who took what. Every interaction that is happening on the shelves for all the products, for all the customers, is an event graph. And you have to keep up with that event graph because events are happening continuously, people are moving continuously, and you can't fall back. And because this is a distributed system, there is no guarantee that events, even though they are time-stamped, are received in exactly the order in which they happen. So the return of someone's item might actually come to you before your take. And because there is uncertainty associated with what was returned or what was taken, you need to be able to not just know and make an accurate prediction for that particular event. You also need to know how that event works in correlation with things that are happening prior to that. We needed to know the item selection, and all of this needs to get eventually reflected in the app. So the app is the portal or the user interface for what the user sees. But behind the scenes, a lot of the core applications are working on these. The next stage of this is, we think about this as the things that are happening in the store, but there is a large part of Amazon's ordering systems and platform capabilities, our foundational capabilities and our foundational services that we also use. And we benefited a lot from Amazon.com's core systems, but in a lot of cases we had to make changes as it applies to physical stores. For instance, when you order an item on Amazon, and between the time that you order an item and it ships, there is a little bit of a latency, so you can actually run your services with a little bit more relaxed time window. But in our store, in a physical store environment, the time when you pick up an item and when you leave is just seconds. So everything gets compressed. So you have to think about those things. We introduced this notion of allowing people to be able to do returnless refunds. It was very simple for customers. You didn't need to bring the products. It was received very well. But there's a lot of work that goes behind the scenes to be able to make sure that all the right systems understand what is happening when a refund gets initiated, and all the way back from crediting the customer to be able to making sure that the inventory is accurate, and every other thing that needs to happen from an ordering system standpoint. So that we had to build a lot of applications in that vein. Of course, every other single thing that any other retail store needs, with pricing, merchandising management, inventory management, were all part of what we needed to build in this. I touched on some of the research science application. We had to build several algorithms to be able to know customer account location, but also make an association of the customer account to the right, association of the right products that they were interacting with to the right customer account. Those algorithms required a lot of computational power, but they also have to operate under a very, very strict latency budget. As I said, people move around continuously, actions are happening continuously, so you can be in a situation where you're trying to predict this tuple of customer account, product, and whether it was a take or a return, and suddenly fall drastically behind. You have to keep up as people are shopping. That was important. In addition, our research algorithms are only beneficial if they are constantly changing and adapting to the data that is available to them. And so we had to build an entire system that automatically allows us to be able to understand, incorporate new data, and be able to train our algorithms, and to know that if we were making a change in our algorithms, and if we were to deploy it in a set of stores or a subset of stores, how would it work versus the existing set of algorithms that are currently running in the store. So the faster we can close that loop, the quicker we can make changes, and the better it is for customers. The last set of things that I wanted to talk about is this notion of sensors. Our algorithms don't really get a chance to showcase what they have to do if we didn't also have a highly available set of sensors. We built our own set of cameras. They're very specific. Remember, a lot of the problems that we are solving, our cameras are in the ceiling. They are significantly farther away from products. So we had to build very purpose-built cameras. We had to make sure that we had the right optical labs, the right reliability labs, in order to be able to test the cameras that we were building for our specific use cases. We needed to control other aspects of the stack in terms of, but also be resilient to things that we knew that we couldn't control. We can control some aspects of the networking, but we know that by and large, once we go outside the bounds of the store, we are subject to whatever the vagaries are that might happen in any external environment. So we had to be very resilient to things of that nature. The motto that I wanted to share with you, and it's something that the team used in there were many times when we had a lot of immediate success in the things that we tried, and there were many aspects when there were a bunch of things that we tried and they just didn't work, and we had to keep trying again and again. And this particular phrase was always appealing to me, and it's something that we used in order to keep us going to be able to deliver on this vision that as long as we were not violating any laws of physics, we were confident that we could build this experience. It was not impossible, it just hadn't been done before. And so it was an incredibly powerful statement for us to recognize the fact that while these applications were pushing the state of the art in several computer vision algorithms, while they were pushing the state of the art in our ability to be able to build a distributed system that is able to balance computation on device and in the cloud, and being able to intelligently do that, we were working within the bounds of physics and what is possible. And so we knew that this experience was there. So even when, in any research example, while things were not working right, we always went back to this to say, we can get this working. We know how to do this. We don't know quite yet how, but it will work because we were very stubborn on this vision that we can deliver on this experience for customers. We have 12 Amazon Go stores today, as I said, in Seattle, Chicago, San Francisco, and most recently in New York. And customers, they've loved the experience so far. They've described it as magical. And they can't wait. We get an inordinate amount of requests to open it in many cities, even in cities that we have not yet been in. And it's very exciting to see that. But the thing that I wanted to leave you with is we've come a long way, but it's still day one for us at Amazon, and we're just getting started. The power of this technology goes well beyond these 12 stores. The potential for computer vision and machine learning to to be able to create the kinds of stellar experiences that customers come to love is truly great to see these days. So thank you.